So now, as I said, if we want to measure the acceleration of free fall using ramp and trolley, we have to know what is the variables. Independent variable. We said the independent variable is what? Is the velocity, final velocity, or the velocity. Dependent variable is time. Okay, controlled variables would be the same height and same trolley being used. The apparatus required طبعا, this is the required apparatus. Okay. And instead of stopwatch, if you want to make more accurate experiments, you have to replace a stopwatch with what? Light gates connected to data logger. Okay. Now the method, we have this trolley. It starts falling from this height. Okay. So it will move this distance. We can measure the velocity here. Okay. So now we have final velocity and we have time taken. Okay. So this is the steps. If we want to use data, if we want to use the light gates to measure the time, okay, so we need this part. As I said before, this will be the distance, okay, to the light gates, and the light gates will measure the time taken from this point to this point. And because this is a very small distance, we can say this is what the speed of the car at this moment. Okay. So now we'll start the timing on the software, making sure it's set to record instantaneous velocity, release the trolley, and start the stopwatch. As the cars pass the light gates, stop the stopwatch. Also, light gates, as I said, light gates can measure the time automatically. Repeat procedure 3 times to avoid or to reduce the effect of reaction time if you use a stopwatch. Okay, and of course ignore the anomalous point or anomalous reading. This reduce error of, as we said, human reaction time. Okay, we can repeat 5 times with different final velocity and different time. So the time will be different, varying. The height of the trolley is dropped from for each reading. This cause a variation of V is recorded by the light gates and at which that is recorded using the stopwatch. Okay. So now, any question until now? This is the equation for the straight line. Okay, so now if you want to measure the G, we will take this V equal AT. So now, because we start from rest, so U equals 0. So now if we want to know what is acceleration, which is acceleration of free fall, so G will equal gradient of the line. So very important to know in this experiment, the gradient will be V, change in V over change in T. Okay. Okay. And this is the equation. Okay, give me about 2 or 3 minutes because the pen. Okay, 12. Okay, now we will continue. So now we know all of this. Evaluating experiment. What is the error sources? Systematic error. Make sure for each repeat reading that trolley is released from the same point. The code should be measured carefully so value the D is accurate. Yani you have to measure the card with more than 1 time, 3 times, and find the average. I'm talking about this part. Okay, you have to measure it. Finally, we have random errors, okay, and safety considerations, and I asked you to read all of this. Now, we will move to Newton's third law of motion. So, any question in the last part? Do you have any question, man?
No, mister.
Mirora, do you have any question?
No.
Okay. Now we'll start Newton's third law of motion. Who can tell me what Newton's third law states? Ah, man.
Uh, when two bodies interact, the forces they exert on each other are equal in size, act in opposite directions, and at the same time.
Okay, so now any forces will obey the Newton third law if we have two objects. We need two objects. Okay, and forces equal and opposite and same time. So if you want to talk about Newton's third law, you need all of this. You have two objects because we need force action and reaction force. The forces must be equal size and opposite direction and same type of forces. Okay? If he asked you to write what's meant by Newton's third law, whenever two bodies interact, the forces they exert on each other are equal in size but opposite direction and same time. Okay? Newton's third law explains the following important principle about forces. All forces arise in pairs, so there is no single force. Because if we have action force, we have reaction force. If object A exerts a force on object B, then object B also exerts an equal and opposite force on object A. Okay, this is what's meant by Newton's third law. Force pairs are same type. For example, if object A exerts a gravitational force on object B, then object B exerts an equal and opposite gravitational force on object A. Same type, gravitational, gravitation. Newton's third law explains the forces that enable someone to walk. So, for example, in image 1, if you push the surface backward, the surface also will push you forward. So we have push force and the push force, same type, and the opposite direction and same size. And one force affects the surface, the second force affects the foot. Okay? Any question until now? Okay. Also, in this part, we have a gravitational force. Okay, gravitational force. What it means? It means if the Earth attract. So as you see, I will make it bigger. Okay, so now we have FPG, and FGP. FGP is the force exerted by the ground on the person. This is why we call this FGP, from ground to person. Okay? Okay, pushing them forward. Okay, this is because what? Because person push the ground backward. So FPG is the force exerted by the person on the ground. Okay? So now, if we have this is the Earth surface, and we have an apple. What happened to this apple, man? It will fall, right?
Yes.
So where is action force and where is the reaction force?
The action force is falling, and the action force is when it hits the Earth surface.
Sorry, again?
The action force it is when it hits the Earth's surface, and the reaction is when it bounces back.
Okay, so tell me, what is the type of force now? You said
Wait.
force 1 is weight, right?
Yes.
Okay, what is the second force?
I'm not sure.
Okay, Merula, what do you think? Where is action and where is the reaction force?
The reaction force. The action is when the apple hits the Earth's surface. Reaction is when the Earth's surface exerts a force on the apple.
Sorry, again, what is the first force you said?
When the apple hits the Earth's surface.
Okay,
And the reaction is when the Earth's surface exerts a force on the apple.
no, because I'm talking about the apple in this position.
Oh, there are two forces, weight and air resistance.
So now we have the first force, gravitational force. So we can write Earth attract the apple downwards, right? Due to gravity, right? Okay, what is the reaction force? This is the reaction force. The reaction force is the apple attract the Earth upward. Now look, we have same type of forces, attraction, attract. Okay, and we have two different objects, the apple and the Earth. Okay, and same size and opposite direction. The apple attract the Earth attract the apple. Same size and opposite direction. Do you understand, man?
Yes, mister. So what's the reaction force?
The reaction force. What is the action force?
Wait.
Weight.
Yeah, the action force.
Action force. Weight. What's meant by weight? The gravitational force from Earth to
yes
to the apple, right?
from Earth to the apple. Yes.
Now the reaction you have to replace. يعني بص كده شوف معي. What is action and what is reaction? It's very easy. If we said the Earth attract the apple downward, right? This is gravity, okay?
Yes.
So now we want to write what is the reaction force. Just replace Earth with apple. Change the places. So now reaction, the apple attract the Earth, okay, upward. Now do you understand?
Attracts the. Okay. Yes. Okay.
Maybe يعني it doesn't make sense, yeah, right?
Yeah, but how does the apple attract the Earth?
Okay. Now, if we have apple, what is the mass of apple? 100 gram, okay? Okay. What is the weight of apple?
About 1 kilo.
About 1
Kilo.
man.
Kilogram.
1 Newton man.
Oh.
Okay,
yes,
so now what it means, man? It means because the weight of apple is 1 Newton, it means the earth attract the apple with 1 Newton force. Right? So now,
Yes.
if the earth attract the apple with 1 Newton, what is the reaction force? The apple will attract the earth with also 1 Newton, right?
Yes.
Is 1 Newton can move the earth upward?
No.
So this is why we have a reaction force, but we can't feel it. If you won't feel it, you need object with the same masses, right? Like what? Action and reaction, it will be more, it will make sense if we are talking about planets. Like why? Like what? Like planets with each other, or the sun and the planet, like this, the Earth and the Moon, all of this, because they have large masses. Okay.
Yes. Okay, makes sense.
But if you are talking about one object is very big, large mass, and the second one is very small, so the force is exerted, but there is no effect of it. You can't see the effect. Okay. Also, I have another example. If you want to raise your pen upward, what is the action force, man?
Raise the pen upward.
Ah,
The action force will be you attract the apple upwards.
so now you want to raise this object upward. Yani you have an apple, okay, and this is your hand. Okay, so you
Yes.
want to move the apple upward. Okay,
Okay.
so now what is action force? Action force on apple. Okay,
Yes.
force from hand to what?
To apple.
Okay, now what is the reaction force?
The gravitational force of apple.
No, force from apple to hand,
Yeah, which is the weight of the apple, right?
which is due to the weight of the apple. But be careful, don't use weight of apple. Okay?
Okay.
Because we said if you make push up, so apple will push down. Same type. You have to use same word, same type of forces.
Okay.
Okay? So now you are saying the hand push the apple upward. Then if you said the weight of the apple downward, now the weight is gravity, and pushing up is another type of force. So we can't use these terms. Okay?
Okay.
So if
Yes.
I asked you what is the action, what is the reaction, you have to use same type of forces. Like what? Like if you are talking about Earth and and the Moon, مثلا. This is Earth and this is Moon. Okay? So now we can say, there is attraction force or gravitational force from Earth to the Moon, and gravitational force from the Moon to the Earth. Okay.
Okay. Yes. Makes sense.
So from Earth to the Moon, this one from Earth to the Moon. Okay. And from Moon to Earth. Okay. Timan, do you understand?
Yes, I understand this.
Mirola?
Yes.
Okay. Now I have another example. I have a car. Okay. Moving with a constant speed. Okay. Now we want to talk about Newton's first law. What is the forces affect the car in Newton's with respect to Newton's first law? Mirola.
There is none.
There is none what?
There are no forces
لا,
affecting.
there is no resultant force, but because the object is moving with a constant speed on the surface of Earth, it has two forces equal size and opposite direction, Mirola.
Weight and the normal reaction force.
What is Mirola, do you know I'm talking about what? Newton's first law.
Yes.
So, okay, now what is Newton's first law?
Objects in motion stay in motion unless an external force.
Okay, what is the all forces affect the car?
Weight.
How many forces do you know?
Air resistance and
Okay,
direction of motion.
and the forward force.
Okay.
So we have applied force. Okay, and we have a resistance. Equal size and opposite direction. Okay, and also we have weight and reaction force. Right? Okay,
Right.
so because the car is at rest for zeros. Okay, it's standing on the surface, weight equal reaction force, and because it's moving forward with a constant speed, now force forward equal force backward. Okay, now this is what Newton's first law only. Okay, man.
Okay, Mr.
Okay, now what if we want to talk about Newton's third law? What is the forces in Newton's third law?
The force, the applied force, and no, they're not. The weight and the normal force.
The weight and
Normal force.
normal force. Sure.
Let me think. Okay.
Is weight and the normal force same type of forces, yeah, man?
That's why it's wrong. Yes.
Huh?
So it's no.
Okay.
This is wrong. So it's applied force and air resistance.
Is applied force and air resistance same type, man?
No.
Okay, now where is the Newton third law? Where is the forces obey Newton third law? The car push the ground backward, so the ground will push the car forward. This is the Newton third law.
If I said the car pushes the earth downwards and the earth pushes the car upwards.
No. Because the car is standing on the surface of the earth. How the car now pushes the earth upward?
It has to like
Okay.
bounce.
If the object in air like this, okay, and the surface is here, we can say what? Downward and upward. Okay, because this is up and this is down. Now the car is standing on the surface of the earth. There is no up and down, yeah, man. Okay. So you can't say the car attract the earth upward because the car is not at the upper level. Okay.
Okay.
So now to move, you have to push the earth backward, so the earth will push you upward. Forward.
Yes.
Okay.
Okay.
Same type of forces. I said push and push, back and forward, right? And also I mentioned two different objects. Okay.
Okay.
What about if you are swimming? Now what is action and reaction force?
You push the water backwards. The water will push you forward.
And what?
The water pushes you forward.
And the water pushes you forward. Okay, right. What about the rocket, Mirola? Mirola,
Yes.
what about the rocket? How the rocket is moving up?
By the gas pushing
Okay, so now,
downwards.
where is the Newton third law in this case?
Uh, Gas is pushing downwards on the surface of the Earth.
Okay, where is action and where is the reaction force?
The action is the gas pushing downwards.
No. The action is the rocket push the gas downwards.
Oh,
Rocket push gas downwards. Okay. Now, where is the reaction?
gas pushes the rocket upwards.
Yes. Okay. Now, do you understand what's meant by action and reaction?
Yes.
Sure. All of you understand, man.
Yes, Mr.
So every time you will think about action and reaction, you have to talk about two different objects, same type of forces, same size and opposite direction. Okay? So this is the four things we need to talk about Newton's third law. Two different objects, the forces must be opposite direction, same size and same time. Okay?
Yes, Mr.
Okay. Now we will talk about this part. One force is from the foot that pushes the ground backward. The other is an equal and opposite force from the ground that pushes the foot forward. The Newton's third law acts on two different objects. Newton's first law involves forces act on a single object. So if you are talking about only one object, you are talking about Newton's first law. Okay? Okay, now we have the first question. I will ask Mirola to solve this question.
B.
B. Why you choose B, Mirola?
Because it's about two objects, not one.
Yes, he said not correct for Newton's third law, and Newton's third law need two objects, and he said the forces act on the same object. It means we have only one object. Okay? Okay, man. Question 2.
C.
C. Do you agree, Mirola?
I'm still reading.
You still read. Okay. Okay, Mirola, I'm waiting for you.
I think it's A.
You think it's A. Okay, now, Mirola, can you read?
No, sorry. I think it's C. Yeah.
C, because they must be equal, okay, but opposite direction, right?
Yes.
Okay, now, Mirola, we need question 4. A, B, C, D.
Is it C?
Man, do you agree or disagree?
See, Mr.
C, yes, correct. C, because this is 90 degree and this is opposite and this is the hypotenuse. So if you want hypotenuse, it will be opposite over sine theta. Okay, we will use sine. Now it's your turn, man. Question 7.
I think it's Q and S, so C.
C. What about
Yeah.
you, Merola?
I think it's B.
You think it's B. Okay, now he said Newton's third law. Which pair of forces obey Newton's third law, right? So now we have the floor exert a force on person. So now we have floor to person. The person exert force on the trolley. Person, trolley. The trolley exert force on person. Trolley to person. Okay, so now the total drag force on the trolley. Trolley only. So now we need Newton's third law, Merola. What do you think?
Person to trolley and trolley to person, so B.
Okay, what do you think, man?
It's B, Mr.
It's B, huh? So
Yes.
you choose Q because what? Q and S. S is a drag force affect what?
The trolley.
And the Q is what? From person to trolley. So where is action and reaction here? Okay, and there is no same type, right?
Right, Mr.
So B is the correct answer. Be careful, man. Okay, because this is easy question and you need to make a focus like what I did. I said from floor to person, from person to trolley, from trolley to person. Now we have trolley, person, person, trolley. This is action and reaction. Okay?
Okay, Mr.
Okay. Let's move to the next. Now we'll talk about this question. Okay, so I will give you 1 minute to read it and I will start with you, man.
Mr. I think the readings will decrease as the left.
This
Right,
question
Mr.
has 6 marks, man. So you need to tell me the answer for 6 marks if you want.
I don't know this question, mister.
You don't understand. What about you, Mirula?
Uh, do I talk about the lift being at rest first?
Okay.
Okay,
first we have to decide, okay, what is the force gives the reading of the scale? Because he said the lift moves upward with a constant velocity. Okay, then decelerate to rest. Okay, so explain the reading on the scale. So first you have to decide what is the reading on the scale. Okay, what is the force? Give us the reading of the scale. So first constant velocity, then decelerate to rest. Okay, so first, what is the force? Give us the reading on the scale. Do you know, Ma'an, what is the force? Give us the reading on the scale.
The what, mister?
What is the force? Give us the reading on the scale. Yani you are standing on the scale. Okay?
Wait.
Here. Okay? So what is the force give you the
Okay.
reading on the scale?
Wait.
Weight. You think the weight is the reading on the
Yes.
scale. The weight give you the reading on the scale, right? But in fact, you can't write the weight is the force give you the reading. Tell me why. Do you
Why?
have a balance at home, man?
No.
Okay. Okay, we will suppose you have a balance. Okay. لو انت عندك balance at home, okay, and you put the balance at the surface of the earth and you stand on it, he will give you the reading, for example, 60 kilogram. Okay. But if you use this balance on your bed, حطيته on your bed, you will see the reading is, for example, 40 kilogram. Is your weight change?
Less than.
But in fact, is your weight change? No. But the reading it change. Do you know why? Because the reading on the
No.
balance is the reaction force from the balance to your body. Okay? So we can say the reading of the balance is the force from the balance or from the left بقى, because the balance on the left. From the left to the person. Okay, so this is the first. The reading of balance or the balance on the balance is due to the force exerted from what? From the left or from the scale, from the balance on the person, on the student, yeah. The force of the left,
yes,
or the balance on what? On the student. Okay? We can call this force with what? The reaction A force, okay? On the student. Okay, now. So, now, with constant velocity, what is the relationship between the weight of the person and the force from balance to the person? We have weight of the person down and we have force up. Okay, so now which one is greater or they are equal?
The normal force will increase.
Now we have a constant velocity. What it means by constant velocity? At constant velocity, resultant force must equal كم معا؟
The resultant force of what exactly?
Yes. At constant velocity. What is resultant force
Mr.
equal?
Your voice is lagging.
Resultant
Zero.
force معا equal what? Equal 0, right? What's the meaning of it?
I told you 0, Mr. Can you hear
Okay,
me?
so what it means? It means the reading on the scale is what? Equal to weight. Equal 6 600 Newton. So until now, do you understand, Mirula?
Kind of.
Huh?
Kind of.
You don't understand?
I don't understand the force of the lift.
Okay,
Or
now
the spirit of the
now
student.
the student is standing on the balance, okay? Okay, and
Okay.
the lift is moving with a constant speed. What it means? It means the person also is moving with a constant speed, right?
Right.
Okay, now what is the force affect this person? Weight downward,
The,
right?
yes.
And the lift upward.
Okay.
Okay, and what is the reading of the scale, Mirola?
600.
The force from the left upward. Okay,
Okay.
so now as he moving with a constant velocity, the downward force weight equals upward force, which is the force from left to the person, which is the reading of the scale. Okay,
Doesn't the lift also exert a force on the weighing scale?
from where we have the normal force? From the left
Yes.
on the person, or from the scale on the person, right? This is why I said we can write reaction force. Okay?
Okay.
You can say the normal reaction force from the left to the person, or the normal reaction force from the balance to the person. It is the same. This will give you the reading of balance. What else?
I'm just confused.
Confused between what and what?
Shouldn't the lift exert a force on the weighing scale, not the person?
The lift will exert a force on what?
The weighing scale.
Okay. What else?
And the person.
And what about this force? It will move to the person.
Yes.
Right? Because the person is standing on it. And we need the reading. Is the reading of balance depends on the force exerted on the balance due to the lift, or it will be affected by the person standing on it?
The person standing on it.
Okay. And the reading is not the weight directly, it will be the reaction force from the scale to the person.
Okay.
Okay?
Okay.
And you can make an experiment at home if you have balance. You can place the balance on the surface of Earth, okay? And stand on it. You will see your weight or your mass, okay?
Okay.
After that, place this balance on the or your bed in your bed and stand on it. You and take the reading. You will see the reading is less. Okay?
Okay.
What
Yes.
it means? It means the reading is what is the force from the scale, the normal force from the scale to the person. It is not the weight of the person. It is not due to the weight only, huh?
Okay.
So now let's read again. The reading on the balance is due to what? The force of the left or the scale on the student, which is upward. Okay? Okay? So I can
Okay.
write weight and force from what? Left to person. Okay? And we have two different action. We have constant velocity and decelerate. So we are talking about constant velocity. For constant velocity, what is the resultant force affect the person? It will be zero. What it means? It means the force up equal force down. Okay, so the reading of the scale is equal to the weight equal 600. Do you understand, Miroda?
Yeah, kind of.
Okay, man, what do you think? It is easy now?
Mister, can you go through it step by step quickly, please?
The
Like,
reading on the balance is due to the force of the lift or the scale on the person. Okay?
okay.
While if the lift at rest or moving with a constant speed, resultant force equal what?
Zero.
Equal zero. It means the force downward, which is weight, equals the force upward, which is the reading of the scale.
Okay, yeah, understand now.
This is why I start with defining what is the reading of the scale. It's due to force of the lift on the person, which is upward. Normal reaction force, upward. Okay?
Okay, yeah, I understand.
This normal is not constant equal weight always. Because, for example, if this is the Earth surface, for example, man, okay? Okay? And we place, for example, a piece of sponge. So now we have a sponge, okay? Then we place the scale,
It's like
okay?
when you stand on the carpet, right? On the balance.
الكاربت يعني مش هتديك الافكت زي السبونج.
Mm.
Then you stand on the scale. Okay? When you stand on the scale, what happen? You will squash or compress the sponge, right?
Yes.
طيب now what happened? You have normal force, okay? And also you have an elastic force from the sponge upward, right? ما هو السبونج, if you press
Yes,
the
right.
sponge will want to what? Like trampoline كده, huh?
Okay, mister.
Okay,
I understand.
and you have weight downward. So now, as you see, why the scale will give you less reading? Because the normal force will be weight minus elastic force. Okay, do you know now? Do you understand why the scale on your bed or on a pillow, for example, will give you not accurate reading?
Mm-hmm.
Okay,
Okay.
because
Yes.
the reading is only the reaction force, okay, from the scale to the person. Okay, Mirola, do you
Okay.
understand now?
Yes.
Okay, I have to remove all of this طبعا. Okay. Okay, now let's continue. What about decelerating? To decelerate, which force must be greater, weight or the force from the scale to the person? To decelerate, the resultant force direction must be what?
Downwards.
Right. So as left decelerate, the resultant force is what? Downward. What's the meaning by saying resultant force must be downward? It means
Weight is more than the
yes,
upward force.
yes, the force from balance or scale on the person, which is a student يعني, less than the weight of her. So what it means, the reading will be the reading of balance will be less than what? 600 Newton. Now do you understand?
Yes,
Mirola, do
and
you
then
understand? Huh?
at the end we will say when it reaches rest, it will go back to 600 newtons, right?
When the lift becomes at rest, it becomes 600 Newton again.
Yes. Yes. Yeah.
Okay?
Mm.
Okay. Okay. Now I prefer to start momentum next lesson because it's long and we need time to take all idea about momentum. Okay? So I don't want to take a part of momentum this lesson and the second part next because I have to repeat what I did. Okay? So we will stop here. Okay? I want to be sure you understand this question because I know this is a hard question and maybe he will give you in the test in a different way. So you have to understand how the scale reading is done. Okay. When you read the scale, sometimes you can find your weight, for example, or your mass, 60 kilogram. Then if you move it on the carpet, it will be, for example, 56 instead of 60, like this. Why we have a change in reading? Because the scale itself give you the reaction force from the scale to the person, not the weight of the person. So do you understand this part, يا جماعة?
Yes, mister.
Any question, Mirola?
No.
Okay, so next time I will start with momentum. Okay, and we will finish momentum. Okay, then we will move to center of gravity and the moment, and we will finish moment in the same class. After that, we will move to Stokes law and Hooke's law like this. Okay.
Mister, when do you expect we'll finish the syllabus?
We will finish the syllabus maybe يعني the second half of August. I'm moving slowly معا because we have only unit 1, okay? And I want to be sure you understand everything before solving. This is why I make a lot of examples, okay? Because I want to be sure you understand it in different ways.
Yes, okay, no problem, mister.
Also, maybe I will send some hard questions in the homework, because I want to see how can you think if you have a hard question. And every time I repeat, every time, if you have a question like this, question with 6 marks, you have to start from the beginning. This question has 6 marks, man, okay? So you have to start from the beginning and step by step. Because if you wrote what is the final reading direct, يعني you said the reading will be equal 600 Newton. So how can you explain? This is why this type of questions, what he want to check how can you think, okay, step by step. And your thinking or your steps must be in order. Okay?
Okay, Mr. And you'll send the homework on Classroom this today or tomorrow?
Today is yes,
Wednesday.
I will send it tomorrow.
Okay, no
If
problem.
it is not today at night, it will be tomorrow.
Okay.
But I will try to make it today at night, because you have to know, man, we have different timing. يعني my timing here is not like your timing. Okay?
You're in Europe?
Yeah.
Okay.
Okay. Yeah, see you soon, inshallah. On Monday,
Bye.
on Sunday, inshallah. Assalamu alaikum.
Okay. Bye, Mr.
Bye.
Bye, Miron.